We're going to continue now with our introduction to rearranging formula, looking at problem number 4, which is P equals T over A minus B. We are going to rearrange this formula for the variable A. Now when we look at the equation solving procedure, the first step says deal with your fraction. If you're not too sure how you're going to go about that with an equation like this, let me draw some parallels here by looking at a much simpler equation. Here we have two numerical values and a single variable versus our expression, which contains 4 variables. Bear with me, we'll walk through the process for this equation and see how it relates to the formula we're working with. So here's our simpler expression. If we want to solve, if we want to eliminate the fraction for this in this situation, we would multiply both sides of the equation by the denominator, which in this case is 10. This causes the denominator on the right hand side to cancel out, and we're left with t on this side equals 5 times 10, or 50 equals t. So now let's go back to our formula that we're trying to rearrange. You see the parallels between this expression and this expression. We needed to eliminate the denominator or the fraction. In this situation, we multiplied by the denominator 10. In this situation, we do exactly the same thing, except our denominator is a little bit more complicated looking. And we're going to multiply both sides of the equation by a minus b. Just as the denominator canceled out in this situation, so it will cancel out in this situation. And we're left with t on the right hand side and this expression on the left hand side. So now we have rearranged our formula, we've eliminated the fraction, and we're left with this expression. This moves us to step number 2 in the equation solving procedure, which helps us to eliminate the parentheses or brackets. Again, let's try looking at a simpler expression with fewer variables. So we're trying to solve for a. So if we leave a in the expression, but replace the other 3 variables with random numbers. What would happen in this situation with the simpler expression is we would use the distributive law and multiply 5 through the bracket, which would leave us with 5 times a, and 5 times 3, 5 times 3. Here, on the more complicated formula that we're trying to rearrange, we'll do exactly the same thing, except it's the variable p that we are distributing through the bracket. This leaves us with, instead of 5 times a, p times a. Instead of 5 times 3, p times b. In this expression, we can go one step further and simplify a little bit more, because we know that 5 times 3 equals 15. But in this situation, we don't know what p, a, or b, what those variables equal, so we're simply left with the expression pa minus pb equals t. And we have eliminated those brackets. Okay, so now we're looking at this expression. We've eliminated the fraction, we've eliminated the brackets, and we're now trying to go to the next step and solve. Again, we're looking to solve for the variable a. Once again, I'm going to try something simpler. I'm going to leave the variable a where it is and replace the other variables and terms with random numbers. Here's my parallel situation. 5a minus 15 equals 12 is kind of similar to pa minus pb equals t. What I would do in this situation, I want to solve for a, so I move any terms that don't contain the variable of interest, a, over to the other side of the equation. So here I've got negative 15, so I add 15 to this side and to this side. minus 15 plus 15 is 0, leaving me with 5a on the left-hand side, and 12 plus 15 is 27. If I return now to the equation that we're actually working on, I can see how I want PA by itself because it contains the variable of interest A, just the same way as I wanted 5a by itself in my parallel equation. So I want PA by itself on the left-hand side, and I want to get this negative PB term over to the other side of the equation. So in the same way that I added 15 to move the negative 15 term over to the other side of the equation, I've got negative b here, so I'm PB here, so I'm going to add PB to both sides. I'm left with PA alone on the left-hand side, and the expression T plus BB on the right-hand side. No like terms here that I can gather, no way to simplify it. As I did here, I was able to add 12 plus 15 and get 27, but here, obviously, I can't add T plus PB. I don't know the value of any of those variables. So I'm left with this expression, and I'm a step closer to my final solution. I now have the only term that contains A, the variable of interest, by itself, isolated on the left-hand side, and all the other terms are on the right-hand side. Okay, so this is where we left off, and we are on to our final step now, where we can solve for the variable of interest. And we do that by dividing by the coefficient, in this case p. And if we just go back to our parallel situation again, with 5a minus 27, 5a equals 27, to solve that, we would divide by 5, leaving us with a is equal to 27 over 5, which is also equal to 5.4. In this situation, instead of dividing by 5, I divide by p, again, the coefficient of the variable of interest. I'm left with a on the left-hand side, that's what I'm trying to solve for. And on the right-hand side, I have this expression, T plus PB over P, and that's because I had to divide by P on both sides of the equation. So I've isolated A, the variable of interest, solved for A, and this is my rearranged formula.